Good day. Welcome to our fifth video on this understanding spatial modeling in ERDAS Imagine. Today we're going to continue with the model that we created in the past 4 videos and improve that video further up until we calculate our results. So I'm going to load the model in our viewer, but before I make any changes to the model, we need to understand the outputs that we created previously. So I'm going to load the outputs, mainly the direction and the magnitude images. So these are the direction and the magnitude images, both of them. It's important that I understand the kind of values that I have in the magnitude. So magnitude is basically the amount of change over a period of time. Right? So we've managed to class it into 5 classes, with 1 being the least amount of change and 5 being the very high change over the period of time. And if I also look at the direction, which is basically whether the change was it negative or positive or no change whatsoever. So I'm going to view my metadata. So I only have 3 classes, with 1 being the class that is no change, 2 and 3 conform to negative on 2 and positive change on 3. But obviously I'll need to add tables that will allow me to identify these classes better. So that's what we're going to be doing in this exercise, adding those tables and classifying our images further. So I'm just going to close our models. I'm going to close our images and extend my screen better so that I can see my models better. So if I expand the direction sub-model, I'll notice that I have 3 classes that I've created, with class 1 being no change, basically 0 direction between my 2 seasons, and then class 2 transform to negative change, class 3 transform to a positive change. If I view again on my magnitude image, I see that I'm calculating a change in magnitude based on the Euclidean distance algorithm. Right? In that I also have 3 classes, where if the value is equal to 0, that means we do not have change. Between 0 and 1, very low change. 1 and 2, medium change. And then 2 to 3, high change. With the highest being greater than 3, we get highest change. Very high change. So those are the 5 classes that we have for our magnitude. So we need to identify these classes. We need to map these classes to our understanding. But the first thing that we need to do now is we need to put our magnitude and our direction images together. To do that, we're going to use a criteria operator. And inside the criteria operator, I see at the moment it only has takes one input. But because I'm going to use my change direction and my change magnitude from my criteria, I'm going to add another port. So in the spatial model ribbon, I see under the operators, I have an add port icon. I'm going to click on it, and then it adds 2 ports. I'm just going to zoom in so that we can see better. So there we are. We have 2 ports that we've added. So what I want to do with these ports is I want to put my direction image. So direction is input 1. It's important that I note that. And my magnitude will be under input 2. So remember, we said, I'm just going to move it here so that I can see it better. Or let me use the auto layout so that everything is arranged better. So this is the model that I'm going to build from. So remember, we said our magnitude has 5 classes, whereas our direction has 3 classes. Right? I'm going to go into my model. So we're going to define our classes based on our direction and our magnitude. So the first instance is class 1, which basically is classes of no direction of change as well as no magnitude change. So that means my input 1 has to be equal to class 1, add another criteria, and my magnitude also equal to 1. So this is my class of no change over a period of time. Class 1. I add another class 2. So now I need to define my negative classes first, and then I'll define classes that have negative change later. So input class 2, that is my direction. Negative change, we said it's class 2, that is negative change. And then we look at the amount of change from input number 2, which is our magnitude, which is now equal to 1. That's my first magnitude. Then I define the next one, which is class 3, which then is equal to, so I'm still defining my negative change classes. So this then is class 2. I add another variable for my input 2 and equal to 3 for my equal to 2 for my magnitude. I'll continue defining all the classes for all the remaining classes. So now we've defined our 9 classes. Class 2 to class 5, these ones, they represent negative change. Whereas class 6 to class 9 represent positive change classes. So there'll be 4 negative change classes and 4 positive change classes. I'll click OK. My output. So this is our criteria that we've defined for those 2. I can write this to an output, raster output, and I can load. And I'm going to add an operator, port output, so the port input, so that I'll be able to give a name to my image, CVA output. And I click OK. So what we're going to do is we're going to run this classification so that we see if we've defined all our criteria correctly or if we've left any other data sets. I'm going to click run. So the model takes a while to run, so after completion I can see that all the operators have run successfully. So now I can load CVA image. I'm going to load it as a pseudo color image so that I can see the styles and the colors. Display attribute, so when you open it, don't panic because you see a black screen. It's because by default all the classes have been assigned one value, but you can change the different class colors. Right, now I can see my class 1, my class 2. I'm just assigning random colors so that we can see save changes. I'm going to create no. So back to our model. Let's just save our model as we edit it. Save it. Click OK. So our model is saved. Now we have a backup of our model should we make any changes to the model. Okay. So now we need to add a few operators here that allows us to add coloring and value classes to our final CVA output. Our tables, rather to create our coloring and our attribute values, we need to add a few custom table input operators. So I'll search for custom table input. I need 2 operators, one to contain the coloring field and the other one to contain the attribute names. So I'll load both of them, just 2, or I can just copy and paste the same operator. And I click on the first one, I name it color table. Alright. And I click on the second one, I call it change class. So these will assist us in identifying which pixels certify which class. I'm going to define my color table. So I double click on the table, color table. The data type for that is going to be color. 9 classes. Sorry, the size will be 9 classes. So add or up until to 9. Click OK. So I've defined my color table. I do the same thing. I'm going to define my attribute, basically my classification in the table that allows me to identify or my change classes. So this is going to be string based. In that I also have 9 classes. So those are the 9 classes that I'm going to have. Sorry, 9 values. So class 0 is basically with the 10th class being our no change, basically no data. Class 1 is where we have no magnitude of change and no direction of change. Those are C's, no vegetation. We can just say no change. Class 2 transforms to, or is conforms to very low vegetation loss. Very low vegetation loss. So now we've defined our class description. Now that we've defined our color tables and our classification values, we now need to proceed to define the Rasa attribute outputs. So this will be under the outputs section, or output group of operators. Then looking for a Rasa attribute output. So we define this for both our attributes. So I will copy both across. The color table, table in, the table type for this will be color. So double click on the red to be color, and attribute name in that case will be color. I do the same for the class description. Class table in. So this creates an attribute table which I now need to add as columns into my final attribute. I need to go to the data generation as I'm generating a new table, and I look for the operator create columns. So now I'll convert these two attributes I can zoom in slightly so that I can see better. So I start with my color values. Attribute values. The name for that will be color attribute, and table type. So I actually don't need to do this way. Now create, click add ports. I copy this attribute values, change the name to now, just more slightly, I need to add another attribute for attaching attributes. So attach attributes. It takes a raster in. The raster is going to come from this operator, and it takes the attribute in. So this then gets attached to our final attribute or my final output dataset, like that. So now I've managed to assign my colors and my class names to my attribute raster. I can add these into a single operator. So into a single submodel, create submodel. Then I call this, rename this to CVA final. I click OK. So remember our first output had no colors in, right? So we had no colors assigned and we didn't have a description for our classes. So let's run this process again. Let's run the model and we can compare the results. When our model is done running, we can view our outputs. We go to our CVA image so that we can view our final results. So this is the output that we just created. We'll see that the majority of our areas I can compare these results to the input images. False color infrared, there we go. And then this is our magnitude image. This is our 2018 image. That's our 2003 image. This is our hour before image and our after image. And we can see that we have actually gained vegetation on that push, on this area here, and we can see that the area has been identified correctly. Whereas in the yellow areas, such as this one, we have had vegetation loss. So if I compare before image, 2003 image, and my 20 image, I can see the vegetation loss that has happened over the two images in question. And also add statistical variables to our output table, calculating area in hectares. We'll be able to say what is the area change over a period of time. Total area. So we first of all need to determine total area. Combit statistics. The total area for the whole image is 11,000. 112,316. 112,316. Add new column, call it percentage change, and we assign the formula is area divided by 112,316.50 times 100 to give a percentage. So now we can see that 50% of our images show a low vegetation gain, and 35% of our area shows no change over the period of time. Thank you for watching.